Why is Geosynchronous Transfer Orbit, GTO, crucial for ISRO launches? Imagine sending a satellite into space and having it stay perfectly over one spot on Earth. That's what geostationary satellites do, and getting them there is a special journey. When ISRO launches a satellite to reach this position, it doesn't go straight there in one shot. Instead, it first enters a shape called a geosynchronous transfer orbit. Think of it as a halfway point, an elliptical path that takes the satellite from near Earth to the high altitude needed for geostationary orbit. This orbit is shaped like an elongated oval, with the closest point near Earth and the farthest point at about 35,786 kilometers above the surface. The reason ISRO uses this two-step process is all about fuel and efficiency. Launching directly into geostationary orbit would need a lot more fuel, making the satellite heavier and more expensive. By first placing the satellite into GTO, ISRO can save fuel and use smaller engines on the satellite itself to finish the job. The satellite then performs small engine burns to circularize its path and settle into its final position. This method allows ISRO to launch heavier payloads. For example, recently, ISRO used its LVM-3 rocket to send a 4,410 kilogram communications satellite into GTO. That was a record for India, showing how GTO helps ISRO handle larger and more complex missions. The rocket can carry over 4,000 kilograms to GTO and about 8,000 kilograms to low Earth orbit, opening new possibilities for Indian space missions. Getting a satellite into GTO is a precise operation. It requires exact calculations for the launch window, trajectory, and fuel reserves. Mission controllers monitor weather conditions closely because storms or high winds can delay or complicate the launch. During the CMS-03 mission, ISRO had to work through bad weather to ensure the satellite reached its intended orbit. Satellites placed in GTO serve many important roles. They provide communication services across the Indian Ocean region, supporting maritime navigation, military communications, and remote area connectivity. These satellites stay over specific regions for many years, offering continuous coverage. For India, having the ability to launch such satellites independently boosts national security and economic growth. ISRO's success with GTO also paves the way for future projects. The organization plans to increase its launch frequency, aiming for 50 missions a year by 2029. This growth requires more advanced rockets, better infrastructure, and trained personnel. Upgrades to the launch vehicle and the development of cryogenic engines have been driven by the demands of GTO missions. These engines are complex and requiring years of development, especially as India worked to overcome international restrictions on access to certain technologies. Understanding GTO shows how complex space missions are. It's not just about sending a satellite up. It involves careful planning of the path, timing, and fuel. Astronauts and mission teams train extensively to understand these mechanics, ensuring everything runs smoothly from launch to final orbit. Looking ahead, GTO capabilities will help ISRO launch more satellites faster and more efficiently. It also positions India as a potential provider for international clients who need reliable access to space. This growth will support India's ambitions to expand its space industry and develop new technologies, making GTO a key part of the future of Indian space exploration.